Okay, we're in section 3.3, measure of position. And the first thing we want to talk about are standard scores. A standard score is what we call a z-score. So a z, ooh, nice purple color. A z-score or standard score for a variable, for a value is obtained by substituting the mean from the value and dividing the result by subtracting the mean from the value and dividing the result by the standard deviation. By subtracting the mean from the value and dividing the result by the standard deviation. A lot of words, but this is what it really means. So a z-score, or a standard score written with the variable z, is equal to the value that you have minus the mean divided by the standard deviation. So if we're talking about samples, the formula looks like z equals x, the value, minus the mean of the sample divided by the standard deviation. If we're talking about population, which is what we're mostly going to do at first, then it's going to be z equals the value of the data minus the mean of the population over the standard deviation of the population. What this gives is it represents the number of standard deviations the data falls above or below the mean. So z represents the number of standard deviations the data falls above, that's if z is positive, or below, that's if z is negative, below the mean of the population or the sample. So above or below the mean. So what we want to do is practice finding these standard scores. These are going to become really important to us in the next few sections. It doesn't start until, I think, chapter 6, maybe, but it plays a big role in what we do later on. So the first thing we want to do is we're going to do an example. And the example we want to do is we want to find the z-scores for a reaction time. So we're going to get some data and find the z-scores of that data. And the reaction time is that we're looking at is the reaction time to a stimulus has been measured to have mean 2.5 seconds and standard deviation of 0.3 seconds. So we want to find the corresponding z-scores. first one is if they give you that their data point x is 2.7. So that data point is the x value in the formula. And remember, the formula is z equals x minus mu over sigma. So if we want to find the z-score for this, it's z equals 2.7. In this case, mu is our mean, which is 2.5, and the standard deviation is 0.3. So we're going 2.7 minus 2.5 over 0.3. And when you stick it in a calculator, make sure that you put parentheses around the 2.7 minus 2.5 or do it separately. So this becomes 0.2 divided by 0.3, and we get 0.67 if we go to 2 decimal places. So that's our z-score for that data point. So let's find another one. Let's do 3.1. So if we do 3.1, it's going to be z is equal to 3.1 minus 2.5 over 0.3. So this is 0.6 over 0.3 or 2. So there's a z-score of 2. Let's look at another one. Let's do a value of 2.2. So z is equal to 2.2 minus 2.5 over 0.3. And 2.2 minus 2.5 is equal to negative 0.3. And it's okay to have a negative value. So this is negative 1, and it has a z-score of negative 1. So let's ask a different question. What number would be 2 standard deviations below the mean? Now, if z represents the number of standard deviations either above or below, basically it's saying in this equation z equals x minus mu over sigma, where in our problem mu is equal to 2.5 and sigma is equal to 0.3. It's saying that z is negative 2. Negative because it's below, and 2 because it's 2 standard deviations away from it. So we're going to go negative 2 equals x, the thing we want to find, minus 2.5 over 0.3. And then I'll give you a formula for this in a minute, but this is basically what we have to solve. So the first thing we want to do is multiply up by 0.3. So negative 2 times 0.3 gives us x minus 2.5. So let's see, what is negative 2 times 0.3? That's negative 0.6 equals x minus 2.5. And now we want to add that 2.5 to both sides. And we get 2.5 minus 0.6 is 1.9 equals x. So the number that would be 2 standard deviations below the mean is 1.9. Now typically what we do with this equation is we actually find a formula for x. So we either want to find z, the standard z-score, or we want to find x, the data value. So if I were to solve for x here, I would get sigma times z equals x minus mu, and then I add the mu over. So mu plus sigma z equals x. This formula is the formula we need to solve for x. Whoops. And this formula is the formula we need to solve for z. So this is a z-score, and this is a data value. All right, we're going to stop there. and we'll go on to percentiles in our next video.